Hello viewers, thanks for watching my video.
There are many so-called science facts we take for granted to be true, but I can think of at least 5 so-called facts that are widely believed but aren't actually true. In fact, they're so ingrained in our psyche that you might not believe what I'm saying and will probably be Googling to double check. And I encourage you to do that because I would too. So what are these facts I'm going to refute? 1. There's no gravity in space. Incorrect. Nothing can go faster than the speed of light. Physics has no such limit. Bees shouldn't be able to fly, according to physics. I'll explain this using physics. Humans evolved from chimps. Absolutely wrong. And the Big Bang explains the creation of the universe. It does not. If you want to know why all these facts are wrong, stay tuned because that's coming up. The misconception is that nothing can break the speed of light because physics says so. The truth of the matter is that physics never put in such a limit. You might say, but Einstein's law of relativity says so. It doesn't actually say that. In fact, we're quite sure that the speed of light limit has been exceeded. What physics tells us is the following. Any massless particle must move at the speed of light. Anything with mass cannot be accelerated to the speed of light because it takes an infinite amount of energy to accelerate a massive particle to the speed of light. So you can only get a massive object infinitesimally close to the speed of light, but never at the speed of light. Most importantly, information cannot travel faster than the speed of light, as this would break causality. Now you might say, but wait, now you're telling me you can't break the speed of light. No, I'm not. Space-time can, for example, expand faster than the speed of light. And we believe this happened in the very early universe during what's called the cosmic inflation epoch. This is when space expanded exponentially in the early universe. This helps explain many mysteries of our universe, like the homogeneity of the cosmic microwave background, the apparent flat geometry of space, and the origin of large-scale structures, which are thought to have arisen as tiny quantum fluctuations got fixed onto large scales. But information never traveled faster than the speed of light. Similarly, there is something called the group velocity of light that can travel faster than c. You can think of this as a pulse of light composed of the sum of various frequencies of light. The bump is the brightest part of the light containing most of its energy. If you were to see this light, it would appear to be dim, then brighten, then dim again. Such a pulse travels at c in the vacuum of space. It travels slower in some media like water or glass. But there are some special materials in which certain frequencies of light exhibit something called anomalous dispersion. Without getting into the details, what this means is that the bump becomes narrower and bunches up in the middle. This bump, as shown in this illustration, travels faster than the bump on the light traveling at c. Since the bump represents most of the energy of the wave, it seems to appear that light energy travels faster than c. So what's going on? Well, here's the key. Although the bump travels faster than c, the leading edge of the pulse travels at the same speed as the leading edge of the pulse in empty space. What's special about the leading edge? This is where the information is contained. It carries the information that, aha, light has arrived. So even in this case, information does not travel faster than the speed of light in a vacuum. This is the main principle of Einstein's theory of special relativity. Why can't information travel faster? Because this would break causality. Something in the future could affect the past, such that the future never occurs, the grandfather paradox. The most visible force on cosmic scales is without a doubt gravity. It keeps our feet firmly planted on the Earth and the Earth in a stable orbit around the Sun. You've probably been told that there's no gravity in space. That's just not true. In fact, gravity is everywhere in space. It has infinite reach. This can be seen in Newton's law of universal gravitation. The r in the denominator is the distance between objects. This number can be as large as you can imagine. Gravity would still be present. It would be weak at very large distances from massive objects, but never zero. This means that the Sun has a non-zero gravitational effect everywhere in the universe, and so does the Earth. In fact, so do you. Again, this is going to be extremely weak the further away you go, but it's never zero. Newton's equation also shows that close to massive objects like the Earth, gravity is quite strong. In fact, You might be surprised to hear that the force of gravity on the International Space Station, which is 250 miles or 400 kilometers away in space, is almost the same as on the surface of the Earth. So why are the astronauts floating when you see them on TV? Well, you feel your weight if you stand right now because gravity of the Earth is pushing you to the ground, and your feet exert a counteracting force upward against your body so you can stand up as the downward force of gravity pulls you down. In space, it's different. The astronauts and the space station have mass, so the Earth's gravity still acts on them. But because of the orbital motion they follow in space, there is a force component going away from the Earth, which is equal and opposite to the force of Earth's gravity. Gravity is still there, being so close to the Earth. In fact, it's about 90% of what it is on the surface of the Earth. But because there's no external contact force pushing or pulling on their body, they feel no weight. They are, in fact, in free fall. An orbiting astronaut and space station is like an untethered falling elevator. You would feel weightless inside for the same reason. The difference is that the satellite is falling so fast to the side that it continuously misses the Earth's surface, allowing it to fall forever. This is what an orbit is. Note that when I say that gravity has infinite reach, it doesn't mean that the gravity of our Sun, Earth, and us has reached out infinitely far away. The effects of gravity travel at the speed of light, that is, the speed of photons. So essentially that means that our gravity extends out to everything that we can see. And everything that we can see also affects us gravitationally to some negligible degree. But the universe is larger than the observable universe, and so we would not feel any of the gravitational effects of any objects whose photons haven't reached us yet, since both photons and gravity. Move on to the story of the biologist and the engineer. The story goes something like this. A biologist and an engineer go to a bar. After a few drinks, the engineer begins talking about math and the biologist about bees. The result of the discussion is that the engineer concludes that according to the laws of aerodynamics, the bumblebee is incapable of flight because it cannot produce enough lift to fly. This story is almost certainly more legend than real, but nevertheless, legends are based on a kernel of truth. The problem can at least be traced back to 1934, when the French zoologist and aeronautical engineer Antoine Magnan came to the conclusion that bees should not be able to fly. How did he come to this conclusion? In short, by measuring the mass of a bee, you can calculate how much force you would need to lift the bee. Then he looked at the wings and computed the maximum lift they could create. He found that the maximum upward lift force would be less than the gravitational force downward. So he concluded that the bee should not be able to fly. Now, since bees clearly can fly, this remained a mystery for over 70 years. But researchers at Caltech and the University of Nevada finally figured it out in the early 2000s. The solution is very interesting. There was a mistaken assumption in Magnan's original calculations. The assumption was that the wings of the bee work in a similar way as the wings of a bird. In order to fly, birds flap their wings up and down. But the thrust or lift that enables the birds to fly is only generated during the downstroke. No lift is generated in the upward stroke of the wings. So roughly speaking, only half of the wing movement is generating lift in birds. As it turns out, bumblebees don't fly like this. They don't fly like birds. They fly like bees, and bees flap their wings back and forth, not up and down. And lift is generated in both the forward and backward stroke. So the rapid rotation of the wing as it flops over and reverses direction, combined with the very fast wing beat, creates more than enough lift for bees to fly. You can somewhat replicate the mechanism of bees flying yourself by treading upright in the water. In other words, by trying to stay afloat in one place, as you move your hand back and forth, the changing angle of your palm creates a lift in both the forward and backward stroke of your arms, keeping you from sinking. In fact, many of the movements in swimming use similar techniques. And while we're on the subject of bees, did you know that bees directly affect human nutrition? We rely on them to pollinate many, if not most, of our fruit and vegetable crops. Without them, we would lose many of these foods. So maintaining the health of bee populations is very important to human health. But the population of Earth's bees is declining, and this is largely due to human encroachment on their habitats.